Other than reliability and validity, another important aspect of developing formal assessments is the notion of standardisation. When we're talking about standardisation, we're actually talking about two things. We're talking about, firstly, the development of norms, and secondly, the rigorously controlled testing procedures. Basically, if we give the personality test or intelligence test to a large group and a wide range of people, then we can identify what the average score is. For example, what the average score is for intelligence or for particular personality aspects such as openness or conscientiousness. In this way, if you do the test, you can compare yourself to the norm. The development of norms gives individual test scores the context to interpret them. For example, the distribution of heights in your class allows you to determine how tall you are relative to your classmates. Similarly, the distribution of scores in an exam allow you to determine how well you did relative to your classmates. You may have heard the term grading to the curve, which is where grades are given to ensure they fit a normal curve. Now, we don't subscribe to that model when we're marking a particular assignment at Western Sydney, but typically we find that anyway, some students will be awarded a fail, most will be awarded a pass and a credit, and some people even receive a distinction, and even a fewer group of people will receive a high distinction. One of the fundamental assumptions and observations of the measurement of psychological phenomena, such as intelligence, is that firstly, people will fall along a continuum of that measurement. And if you look at the scores across all the people, they clump in the middle. In fact, they form a bell-shaped curve and are normally distributed. This means that most scores fall in the mid-range of the scale, and scores are increasingly less frequent as they taper off symmetrically towards the extremes. More people with average scores and fewer people with higher or lower scores. This very useful distribution is known as the normal distribution, which is a very common distribution. For example, if you were to measure the wingspans of large colonies of butterflies, the distribution would be a normal distribution. If you were to measure the amount of sleep you get per night, it would be approximately normally distributed. In fact, many human characteristics such as height, IQ, personality, or examination scores of a large number of people follow the normal distribution. Let's look at IQ, since that's what we're interested in within this lecture. On intelligence tests, the centre of the distribution for each age group, from childhood to late adulthood, is assigned an IQ score of 100. Now, the normal distribution has some statistical properties which allow us to work out the percentage of the population that will score higher or lower than a given score. For example, an IQ of 100, there are 50% of people below this score and 50% of people above. And the farther away we move away from 100, the fewer people who attain the higher or lower score. For the WACE, or the Stanford Binet, or the WISC, the range of scores from 90 to 110 is labelled as average and includes nearly half the population. In fact, 68% of scores fall within one standard deviation of the mean. That is, between 85 and 115 for the commonly used intelligence tests. 95% of scores fall within two standard deviations. That is, if you're talking about IQ, between 70 and 130. This means scores of over 130 only occur in 2.3% of cases. Scores over 145 in an IQ test are about 1 in 1,000 chance. So if you do an IQ test, you take your score and you compare it to the norms of the population. This allows you to find out where you sit in context to others. But not everything is normal distribution though. Some things are what we call negatively skewed, where most scores pile up at the high end of the scale. Look at the picture on the left. I was taught to remember this by looking at the long tail that looks like a skewer. If the skewer is at the lower end, then it's negatively skewed. If I set an easy exam, then most of you would score at the high end, with only some of you getting lower scores. On the other hand, where most scores pile up at the low end of the scale, with the tail or the skewer at the upper end, we call this positively skewed. If you were to give a measure of depression to people who were in a depression group, then it might be normally distributed. But if you were to give the measure to a broad range of people, then it's likely that most people would not be depressed. The scores would bunch up at the lower end, i.e., that is, low symptoms of depression, and only a few at the high end. Wealth and income measured across the general population are also examples where very few people at the top end earning millions of dollars, and most people towards the lower end of the pay scale earning less than $100,000 a year. Although this may seem irrelevant at the moment, it's important to understand these basic concepts because they are fundamental in how scores on intelligence and personality tests are interpreted. To collect these norms, we would have to make sure that the procedures for testing people are all the same. In other words, they're standardised. In terms of the end of semester examination, we attempt to standardise the conditions as much as possible. If some of you are completing the test outside next to a highway, then there's a lot of noise and pollution, whilst others are inside in quiet conditions. Then the procedures for testing are not standardised and may be a measure of distractions rather than a measure of your learning. The reasons for standardisation in these conditions for examinations are similarly important for psychological assessment procedures. So just to summarise, we've looked at psychological assessment for the purposes of measuring individual difference. We have looked at the procedures for constructing and conducting assessments. These fall under the areas of reliability, validity, and standardisation. In looking at standardisation, we've looked also at the assumptions of a normal distribution in a given population.